Hey everybody, here is part 2 of tutorial 2, in which we're going to cover some new material that's going to really move us forward in our ability to create some interesting videos. So first of all, see what I've got here. I've just got a jit.world JJ set up here. It's floating. I put the jit.world on the right for reasons that'll become apparent in a little bit. I've got my jit.gl.camera, and then I created 4 spheres here. As I've indicated in the past, I've color-coded those so I can see which one I'm dealing with, and just so that you're aware, you see 3 of them, and then you see one of them as a background. It's because this one here, we're actually inside this sphere. So this is a 20 meter by 20 meter by 20 meter sphere, and we are 12 meters from the center of the space, meaning the backside of this sphere is 8 meters behind the camera location, and we're looking at the far side of the interior of this sphere. And we'll talk about lighting and how that works later on, but right now we can just know that the light itself is inside the sphere with us, the default light. First thing we're going to do is we're going to look at a new way to play sound files. We're going to look at the SFPlay tilde object, because up until now we've just been dragging sound files into the patch, and that works fine, except it's missing one critical element that we're going to be using today. So we use the SFPlay tilde, which takes 3 arguments. First, it takes a number of channels. We're going to use 2 right now because for now we're dealing with stereo files that have a left ear and a right ear. Second argument just needs to be a big number, like 10,000. This is the amount of memory set aside for this SFPlay to play sound files, and it's not particularly important, but we should put in a big number like 10,000. The third argument is important, and that is whether or not we want a time outlet on this SFPlay, and we do. So we put 1 as our third argument, and that gives us a total of 4 outlets. The first 2 are the left and right sound outlets, file channel 1 output, file channel 2 output, and then the third outlet is our file position, or our time outlet. So how do we get a sound file into the SFPlay? We just drag it and drop it right onto the SFPlay, and it will be loaded. And then to get the sound out, as before, we used an EZDAC tilde, EZDAC, and we'll listen to the left and the right channels of the sound file, and then it takes a couple of messages. It takes seek 0, which rewinds to the beginning of the sound file and plays it. Pause, which does what we'd expect, and resume, which also does what we expect. So seek 0, seek space 0 takes us back to the beginning of the sound file and starts playing. Pause pauses the file. Resume resumes playback, and then out this third outlet, we get the playback time. So let's take a look at how to access that. We need a new object called SnapShot tilde, SnapShot tilde, and we can connect our floating point number box to that. And then SnapShot tilde is one of those objects that requires a connection from the middle outlet of the jit.world to its left inlet, just like the AVG tilde, because it's taking a snapshot of the value of this time outlet every frame, in the same way that the AVG tilde is calculating the average volume of a sound every frame. So when we start it, this is the time. Now the time is expressed here in milliseconds, so 6,913 milliseconds, or 6.9 seconds. So really what we could do here is just add a divide by 1,000 floating point, and that's going to bring us from milliseconds into seconds. So in the computer, when you divide numbers, you use / like this. So far we've worked with plus, which is your regular plus, multiply, which is the asterisk, and divide, which is the / to divide two numbers. So if we divide by 1,000, put our floating point number box back down there, we'll now see a much easier to deal with number in seconds. So when I start at the beginning, it'll start at 0 seconds, and you'll see it count up second by second. All right, so why do we want this? Well, there's two reasons that we want it. One, we might not want all aspects of our video to be responsive to sound. We might be some of them to be responsive to time. So we can do a very simple process where we turn something on or off depending on how much time has elapsed. For instance, we can have one of these spheres turn on and off. So first of all, let's look at how to turn on and off a jit.gl grid shape. It's the enable message. ENABLE, enable $1. And enable $1 takes either a 1 or a 0. So enable 1 turns an object on, and enable 0 turns an object off. So if I want to turn this object off, I can just send it the enable 0 message, and notice the brown object disappears. If I want to turn an object back on, I send it a 1, and the brown sphere reappears. Now, here's something I didn't tell you before, but now it becomes important. The toggle, our friend the toggle that we've already been using, outputs a 1 or a 0. And we can actually hook it up to a number box and see that. When I click it, it sends a 1. When I unclick it, it sends a 0. So if I hook this directly up to my enable, I can turn on and off objects. So if I want an object to come into existence at a certain point, that's a very easy thing to do. For instance, let's say I want it to come into, I happen to know this music, so I know that the first melody part comes in at 3.6 seconds. So I can say, when this time is greater than 3.6 seconds, I want this object to exist. So greater than, I just use a greater than sign, space, and then the value that I want to see if it's greater than, which in this case is 3.6. And then I need one other object that I'm not going to explain right now. It's just anytime you use a greater than or a less than or any kind of comparison object like this, not anytime, but in most cases, you want to change object underneath it when it's being connected to something that wants a 1 or a 0 inlet. So this is a little formula that you want to learn. If I want this object to be enabled starting at 3.6 seconds and remaining enabled thereafter, I say greater than 3.6, meaning when the time elapsed is greater than 3.6 seconds. When that fact changes, turn on the object. When this is true, turn on the object. And the nice thing about this is when it's false, in other words, when the time is less than 3 seconds, it will turn off the object for us. So watch what happens when I go to the beginning. The brown sphere will disappear. And then at 3.6 seconds, it reappears. And it will stay there until I rewind, in which case it will disappear again. So I can drive the rotation of the big surrounding sphere. So I say rotate X, Y, Z, and I'll rotate it on the Y axis. And I can very simply just use the time in seconds to rotate the large surrounding sphere, for instance. And if I'm not happy with the speed of that, I can just do some math on it. Make it rotate twice as fast. So going back to this notion of working with a threshold, this notion of greater than. So here we're working with a threshold of time. When the time is greater than 3.5 seconds, this thing will happen. We can also use this same idea with our analysis of the sound when we're doing sound responsive work. So let's get back into sound responsiveness here. Let's reorganize this material a bit and then go and use our cross tilde to isolate the bass line, which is about at 200 hertz. That's where our juicy bass sounds are going to be. And we will take the average amplitude of those bass sounds, driving the ABG tilde from the middle outlet of the jit.world, and then we can apply that directly to the scale of one of our objects, and probably going to need to multiply that a little bit to make it more effective, and that's going to modulate the size of this blue sphere based on the amplitude of the bass notes. Turn the sound on. Very nice, very responsive. Oh, and there's our brown, it still appears at 3.5 seconds. That's very nice also. So then we can let's try something where we take the frequencies between 200 and 800 hertz, sort of the next step up in frequency range. This is where musical notes, the low end of musical notes, are going to be happening from, you know, about A below middle C to A above middle C, that 2-octave range for those of you who are musically inclined. And we'll take that average amplitude and we'll do something different with it. Instead of simply mapping it directly to some attribute, we're going to use a comparison. We're going to only have something happen when this exceeds a certain threshold. So we see those higher notes are producing a higher value here. So here, when this frequency range gets above about 0.1, greater than 0.1, we could use that as a trigger for something else to happen. So we could drive an enable, for instance, with this exact same formula here. We'll enable this one. So we'll enable that every time the amplitude, average amplitude, goes above 0.1. Let's see what that does. So that's very nice. It syncs up, and that yellow sphere only exists when this amplitude exceeds the threshold that we've specified. But what else can we do? Well, we can do something where we start a process when that certain threshold is exceeded. And for that, we use a different kind of object here called togedge. And togedge gives us an impulse at this left outlet when this condition is met, and then gives us an impulse at the right outlet when the condition is no longer met. So for instance, we could do something like shape cube when the threshold is met, and then back to shape sphere when it drops back down. So this is going to be when the amplitude exceeds 0.1, this will become a cube, and then when it drops back down, it will become a sphere again. Right, so we see that I've set up a condition, and then using togedge, I can have one thing happen when the condition is met. I can have another thing happen when the condition is no longer met. Shape cube, shape sphere. That's fine, but there's also this notion of starting a process. And for that, I'm going to introduce a new object that will be connected to this left outlet. So when the condition is met, a process will begin. And the process is called bline. which is a line of values ramping from one value to another value. And this is another object that takes connection from this middle inlet, because the bline outputs a new value every frame, or every time it receives an impulse. So here, let's say we wanted the sphere to rapidly increase in size and then gradually decrease in size. How do we do that? Well, we'd use a bline. We'd set up a message, and we'd say we want this sphere to jump to a size of 1, and then this is comma space. We want it to decrease down to a size of 0 over 20 frames. So 1 comma space 0 space 20, or 1 comma 0 20 means this is the message to instruct the bline to jump to 1 and then reduce back down to 0 over 20 frames. And then we can send this to the scale of this one, and let's see what happens. Well, first of all, I can just do it manually. Right? Jump to a scale of 1 and then reduce to a scale of 0 over 20 frames. So we can see how that's going to work nicely with the sound. So let's look at one other thing, which is to combine multiple values into a single message, because right now we're limited by this $1. You know, the scale has to be the same in all 3 dimensions. We can only change one rotational value. We can only change one color at a time. So what if we want to change multiple aspects? I'm just going to add another avg tilde. Drive it from the middle outlet of the jit.world. So this is all the frequencies over 800 hertz in this one, all the frequencies between 2 and 800 hertz in this one, and all the frequencies under 200 hertz in this one. And let's just simply combine those to control the color of one of our objects. So this is going to introduce a new object called pack. And pack takes an argument for each value we want to combine. So we're combining 3 values, 3 floating point values. So we're doing pack 0, 0, 0. And we'll take all 3 of our average amplitude outlets and pack them together. Now, we can no longer look at this with a floating point number box, because it's now 3 values all packed together. So if we want to look at it, we have to use the right inlet of a message box. This is a new use of a new inlet. It's the first time we're using a right inlet of anything, I think. So pack into the right inlet of a message box, and see, it's right now it's 0, 0, 0. It's going to show us the combined 3 values of the average of cross 200, 2 to 800, under 200, 2 to 800, and above 800. There's the values right there. So now we can do something with all 3 of those values. We can, for instance, say color $1, $2, $3. That means this first value, which is the average amplitude of the sound under 200 hertz, will become red. And then the middle value, which is the average amplitude of sound between 2 and 800 hertz, will become green. And then the average amplitude of sounds over 800 hertz will become blue. And we can send that right into the object that we want to change. We'll make it this one. So you see it's black right now because there's no sound, and the sound will change the amplitude. So we see bass as redness, and then mid-range sounds make it greener, and then high frequency sounds add some blue in, bringing it towards white.